Hello, everyone. Thanks so much for carving out time in your day, especially those on other continents. I know it's late, so thank you so much. Today, we will be trying to level up your data tools and resources and making some of those context connections with earth science and environmental science for you. I would love to, if you would take this time to put in the chat what grade level you teach and maybe the content area, and that helps me kind of gauge where I go with this presentation. Of course, I am a former teacher and I put in way too much content than can ever be covered. So knowing those things helps me kind of know where to steer this. Thank you, Kimberly, 5th and 6th, Jennifer, 9th, or science. Woohoo! Hello from Puerto Rico. I know that Gail is 8th. Dave, I think you're at a museum. So informal, Margaret, 7th grade, life science. We've got Katrina with high school technology and engineering. Thanks, Scott. Science trainer. Great, great, great. All right, so we've got some biology folks. We've got some tech folks, mostly formal educators. And this is great. Okay, makerspace. Okay, great. Well, let's get started. And a little bit about me. I recognize some of the names here. You may know me, but I have a new role I'm going to share with you. But a little bit about me. I'm originally from South Carolina. I have always been interested in science, environmental science, and earth science. And so I attended the College of Charleston, received a marine geology degree. Actually, it was a geology degree, but I focused on marine geology. I decided that after working as a hydrogeologist for a little bit, that really didn't do it for me. I am too outgoing for that, and so I decided that I really wanted to work in informal and formal education. And so I decided to start off my education career. And so as part of that, I went back to school and got a master's degree, a master's of arts in teaching, and a master's of education in science and math. And during that time, I was awarded a pre-service scholarship award from Space Grant with South Carolina Space Grant. And really that kind of started my whole work with NASA. And so since that time, I've worked with 2 space grants, one South Carolina Space Grant as well as Virginia Space Grant. And that did launch me and even more so into a career with NASA. I taught off and on for a cumulative about 10 years. I've been a science inquiry teacher at a Title I school. That was probably my favorite job. I also have worked in and private institutions as a STEM innovation specialist. So I had that experience, which was great. I did get my certificate. I did my training in middle school science. And for those of you, Margaret and Gail, that work with middle school students, I have one. And bless you for for all that you do for our middle school students. I am a wife and proud mom of 2. I am also a Girl Scout troop leader, but you know what? We sadly closed just about a month ago. So our girls are a little bit older now, but that's kind of sad. But nonetheless, so I moved into this community coordinator role about 7 months ago, and that's a program out of headquarters, but my seat is at Goddard Space Flight Center where Barbie is. And prior to that, I worked at Langley Research Center in Hampton, Virginia. We ran the My NASA Data program. And so I would love to hear in the chat if you have used or know of My NASA Data. Would you please put a 1 or a yes in the or a Y or something like that into the chat? That would let me know. All right. Thank you, Angela. Yes, Sharon. Great. Barbie says yes. Kimberly says yes. All right. Keep it coming. Scott, let's, yeah. And the reason why I mentioned that is, if you're new to using data, and you're really kind of sharpening the saw in terms of your data literacy skills and the resources you use to teach data literacy, that's a really great resource. Fantastic. So we're going to move forward. So Barbie, would you mind launching the results of this poll? What is your experience working with scientific data? Would love to hear and kind of assess, what your experience is. All right. So primarily wrong one, wrong poll. This is the one. Thank you, Barbie. You're so
Yeah,
quick.
I should have numbered them the way you did,
Well,
but
it is all good, girl. It is all good. We'll figure it out.
what is your pre? Oh,
It's okay.
got it.
Here we
Here it
go.
is.
Okay. Okay. What is your experience? Okay, so we have the majority have not worked with scientific data yet. Okay, we have 3 of you who've worked primarily with data visualizations or simulations, which is great. We have 1 that I have used data collected by professionals via an online database. We have 2 that have used data collected by someone else. But largely, folks have not worked with data, and so that actually might shape kind of what I do with what I share with you today, and maybe give you some rationale about why it's important. Not only that you become more proficient in using data, but also engage your students in it. And we'll go ahead and end that poll if that's okay. All right, perfect. Next. All right, so what we've got planned for the next hour, less than the next hour, I'm going to talk to you very briefly about NASA's Earth Science platforms and how we collect data. We're not going to be talking about like remote sensing or the science behind remote sensing and any of that, but if you're interested in how in the world do these satellites collect the data that they do, I have some resources that are shared, as Barbie mentioned, on a Google Doc that you will get at the end. And what I have tried to actually, can I share my screen? Just want to give them a look at what they're going to see as they open this document. Maybe. Oh, there we go. Oh, nope.
Second there. Don't hit stop sharing.
Okay.
Add that.
All good. All good.
Here you go.
Thank you, ma'am. I appreciate that. All right, so I'm going to just show you briefly so you know the level to which, can you see my screen?
Yes.
Perfect. The level to which these resources are, I have links here. I'm featuring everything that I talk about today and more will be featured in this handout. We're really segmenting our resources today in 4 different directions. One is learn, one is find, one is use, and one is connect. And I have resources down here at the bottom that will help you stay connected to me, but also how to receive information about webinars and how to get newsletters in your inbox, et cetera, et cetera. So I will stop sharing at that, and that will come later. And so thank you so much. All right, very briefly, we're going to I'm going to give you an overview of some of the resources on NASA's Earth Observatory. There's a lot of great things, especially for learning for yourself about the Earth system and the processes that are manifesting itself in our dynamic system. But also we have EO Kids, we have Mission Biomes. So these are 2 programs that are really great, especially for that middle school audience, that upper elementary, middle, and then Mission Biomes is quite useful for, I would say, middle school, high school. So for my life science biology teachers, that's Margaret and others. That'll be something that you want to keep your eyes open for and ears to the ground. So I will also talk with you a bit about the challenges, but knowing kind of the background of this group, I might not focus on this, and maybe we'll take more time in getting into the weeds of some of those resources. But what I had initially planned to do was for us to take a dive into some of the resources that may be that may are designed for a more advanced user, but in my humble opinion, how you can use these to inspire and update your curriculum. You don't need to know exactly how to use all the data and all the formats and those things, but you can take some cues from some of these. So I do want to say, feel free to put your questions in the chat. Barbie's going to be monitoring that, and she's also, I've tasked her with, if I get stuck or I'm showing too much of any one thing and time's running out, she's going to keep me on track. So we're going to move right on ahead. I would love at this point, let's hear from you. So I'm showing an image. I would love to hear from you about what do you see? Put in the chat. What do you see in this image? I appreciate Kimberly. Let's see, Melissa. Thank you, Dave. All right, the Caribbean. Yes. Clouds, absolutely. Land and water clouds. Okay, very good. What about, so we definitely see you're identifying, okay, thank you, Angela, the space station, absolutely, mountains, thank you, Bahamas, oh, okay, hey, David Paget, it's good to see you, the space station image, yes, absolutely, and so this is a beautiful shot of the Caribbean from the vantage point of the International Space Station. And this is just one of many platforms that NASA uses to collect data about the Earth. And but I know this group, you guys are, you know that NASA collects data about Earth. But generally, when you talk to kids, they think about human exploration or planetary exploration. They don't think about exploration of our own planet. And so the International Space Station is just one of those platforms, as I mentioned, but there are many, many others. We have the geosynchronous meteorological satellites like GOES and others. We have the major satellite missions that I'm going to talk to you more about in just a moment. But we also have airborne missions, and I also will mention that in a moment. So there are instruments that fly on UAVs and aircraft, especially out of NASA Langley. We had a whole fleet of airplanes that were flying and collecting data, which is pretty cool. We also have high altitude research balloons. In fact, at NASA Wallops, also in Virginia on the Eastern Shore, they have a ballooning program, which is pretty neat. But I want to, let's see if this animation will work. Come on. Let's see. Yes, there it is. But I wanted to mention the importance of programs like Globe. I would love to hear in the chat if you know of Globe or if you're a Globe user, you're collecting data with your students. Please love Globe. I know Sharon loves Globe and I know Dr. Paget loves Globe. So these are ways that you can submit data to NASA using smartphones and iPads and things like that, which is really super neat. And so that's certainly one of those platforms that NASA collects data. Let's see, and I think at this time, Barbie, if you would show the fleet video. And so as she's pulling this up, all right, let's see, she's getting that going. All right. So what she's showing here, we have 23 satellites that we call the fleet, and they're measuring all sorts of things. What you're seeing now is a little bit dated of an animation. I think this one's came out in 2019, but what it's showing here is that NASA satellites are currently orbiting the Earth and they're looking down all the time. They are constantly collecting data about our planet. And so I know we've got some life science teachers, earth science. So these satellites are collecting data about the atmosphere, the biosphere, the cryosphere, hydrosphere, all the spheres of the Earth system, which is fascinating. And but really, I love this this animation. And but the takeaway here that I want you to see and recall is that these satellites collect a lot of data, and we want to help you make sense of those data and want to make it easier for you to use. All right, so if we can go back to the slide deck. Let's see. Tennessee State University has participated in the surface temperature campaign. Oh, nice. Okay, since 2001. Absolutely great. We love the work you do there at the university, Dr. Paget. All right. And so, Barbie, can you launch the next video? This is the one. Yes, perfect. Thank you. Thank you so much. And all right, now let's let this get. All right, looks good from my end. So what you're seeing here, it's a bit busy and it's a bit pixelated, so bear with me, but what you're looking at is an example of what it looks like when satellites are passing over an area on Earth. And so those purple swaths, they show this, it's kind of hard to see. They're like these purple grids that are moving along those orbits. But the purple swaths show the satellite's path as they're passing. And so I want you to imagine those are like grids full of data that are continuously being collected. So, but you can see not only do we show these purple grids, but you can see the yellow streaks. Those are our airborne campaigns that are collecting data in a variety of different locations. And so there's lots of different types of observations that are being made. All right, so if we could go ahead and go to the next slide, please. And I know I'm kind of jump in just a moment to, looking at Earth from space to analyzing or really, trying to scope out the data collections that we have. But what I'm going to try to do is to not burden you with all of these these kind of bigger ideas that don't connect with your classroom teaching and instruction. So in just a moment, what I'm going to try to do is introduce you to EO Kids that will help kind of pair with some of the topics that we mentioned. But before we transition to that, I want you to know that NASA hosts the largest repository of Earth science data. So when we're looking at, so we've got biology data, we've got cryosphere ice data, we have data dating back decades, right? We have hourly data, we've got weekly data, monthly data. So we host a lot of different kinds of data. And so I want you to be aware of this repository because it's a lot. And so when we talk about data volume, we're probably all familiar with what a byte is, right? So that's a single file in a filing system. That's a data file. So we call that a byte. And so what I put here is that this chart shows the sequence of how these files get bigger and bigger, right? And so when we talk about data at NASA, we're talking about petabytes. And 1 petabyte is equal to 1,000 terabytes. And that is equivalent to half of the contents of all the US academic research libraries for just 1 petabyte. So I want you to hold that in your mind. Now take a look at this. So, so along the x-axis is time. Along the y-axis, this is our archives. This is our collections of data in terms of size for petabytes. In 2015, our archive size, or the volume, was 15 petabytes. 10 years later, look at the projected number of petabytes of data in 2025. Almost 250 petabytes of data will be collected about Earth science. And so when we think about our students, who they will be in the year 2025, what their skill sets will be, big data is not going anywhere. And so just for a second, I want to think about the role that data play. And so NASA is equipped, we're really funded to collect data and build information. That's our main job, and make that information and those data publicly accessible. Now, how different end users, what they do with those data, that's really, kind of the jobs of whether it be municipal officials or elected officials and researchers, et cetera. But I want us to think about this. So data is kind of the primary level by which information is developed, by which we derive knowledge and insight, certainly wisdom, but think about impact. And so within the next 20, 30 years, our we've got some wicked problems that our children are going to have to solve. And so if they don't have access to the data and the information to be able to make those decisions, then we're really in trouble. And so I want to leave you with that. And so, as we're looking at this big data, this big data situation that we're going to be blessed with here in the future, there is something called data saturation. And Forbes magazine recently says the rise in ability to collect data has not been matched by the ability to support, filter, and manage them. And so the U.S. Air Force is actually, they've created a data literacy program for their workforce. Also, there is a rise in the number of different measurements that are going to be available to help answer some of these big science questions. And so we need the workforce that is able to work with those. But here's my take on this. Even though I think we had about 75% of us haven't used data ourselves, I know that teachers, you likely have data notebooks full of data about your students. The same kind of processes that you're using to analyze student scores and those things, and to make informed decisions about what kind of instructional practices you use with those different tiers of students, are the same kind of skills that our researchers use. Now, granted, they're leveling up those analytics and machine learning and artificial intelligence, are tools in their toolbox, but everyone can be a data person. So I want you to think about that. And this is so when we look at from K to gray, right? I know that's kind of an overused term. I want us to think about how we scaffold this. And what I like to say is that we're in the business of developing a data-abled citizen. And so in my mind, it takes 3 steps. Well, a lot more than 3 steps, but there are 3 main parts. The data literacy piece is the first and foremost part. So this is where we're teaching kids to collect their own data, organize it, visualize it with graphs and charts, analyze it and interpret it and share it, right? Those are the basic skills. And those are the skills that data fluency and data dexterity, which we're not going to get into those in just with the time that we have and then the needs of this group. But I want you to think about, if we are going to raise and rear data-abled citizens to be able to solve some of these wicked problems we're going to talk about in then we really need to start with that data literacy piece. And there are programs like MyNath Data and Globe that are doing just that. And so, and EO Kids. So we're going to transition over to EO Kids. And but I would be remiss if I did not mention to you NASA Earth Observatory. So I've taken some screenshots of NASA Earth Observatory resources. And so on the left, you will find on this on NASA Earth Observatory, there is this great tool to be able to hunt for different types of resources. So Dr. Pageant mentioned that they're doing surface temperature campaigns. So maybe heat is something he's interested in. We also have a program called NEO, NASA Earth Observations, that offers really easy to use global maps. And so that's that one kind of in the middle with the orange header. Easy to jump in, easy to have students analyze data. You can even change it. I think it goes back about 20 years of some of those data variables. You can look at seasonal variations, etc. Let's go to the bottom middle. NASA Earth Observatory, they have I believe they call it a blog or feature articles. They do an image of the day that and it's really neat to be on kind of working with this team as I see their stories develop. And they're like, hey guys, have you heard about this happening over in this part of the world? And the next thing you know, they're finding satellite imagery and they're developing these stories. So it's so neat to see this group, really cultivate these stories and communicate them. So I highly recommend that if you're in the earth sciences and you're interested in that. The other part, let's say you're not necessarily interested in getting them every day, but you're more interested in seeing what are some of the satellite imagery and earth science processes that are happening in your neck of the woods. Check out the top right. That's called the Earth Explorer. The Earth EO Explorer. You can click your area and you can see all the various stories that have been published. EO Kids is the bottom left, and we're going to talk about that in a second. And then Mission Biomes is another resource. So let's go ahead and we'll see what's next. All right, so the thing that we're going to look at first is the Earth Observatory. Now, I have to tell you that Earth Observatory, sadly, this program has been sunset, and that means that we are no longer making new issues of these, but I believe there's about 20 of them, and they're these online printable PDFs with articles and activities that you can do, and they're generally made for, I believe, ages 9 through 14. And of course, the reading level, if it, they could be appropriate for older students, depending on the needs of the students. But each issue comes with a story focused on satellite imagery and how those data are being used to address an earth science phenomena or event. And then it also features these hands-on activities and that you can do you can do them in a classroom. They're linked to the NGSS standards, but they are also perfect for informal environments. So Dave, if you're in that space education museum that I think you're in, that would be perfect for your group as well. There's actually also a playlist of these hands-on activities being conducted, so you can take a look at that and see how they're run before investing time and energy in them. And then who would it be appropriate for? These girls on the top right, obviously they're younger than it looks like than 9, but so there's a variety and a diversity there of ages that you can use with these activities. Certainly during COVID shutdown, many parents and guardians were using these articles and doing these activities with students. All right, we're going to skip ahead. So briefly, I want to talk to you. I saw this graphic shared last week when I was in Wisconsin, and it was something that kind of stuck out to me. And I want to get this right. I want to make sure I get this right. So give me a second. Let me get caught up. So what I'm showing here is the results of the 2021 World Economic Forum's Global Risk Report. And so this represents the results of what's called the Global Risk Perception Survey, and it's based on insights gathered from nearly 1,000 global experts and leaders. And it's centered out of Canada, with about 8% of the respondents coming from Canada. But the takeaway here, if you look at it, and let me back up. So on the x-axis is the likelihood that people feel that these events, these risks are going to happen. And then on the y-axis is the impact that they perceive that it will have, right, on the world. And so the things I've circled in blue are these issues, these global risks that have increasingly become more linked with environmental issues. So we're looking at climate action failure, infectious disease. So if you're in Globe and they've got the mosquito campaign, which is awesome, biodiversity loss, human environmental damage, extreme weather, natural resource crises, which we're seeing these water crises happen out west, and geophysical disasters. And so, yeah, it's kind of startling, but and if you take a look at some of these outlooks, we can see that some of these environmental issues used to be much further down at the bottom towards the left than they are now. So it's definitely on people's radar. Um, all right, so let me see here. So the next thing I'm going to share, if it'll come up. Nope. Nope. Oh, sorry. I don't know what happened. Can we go? Thank you, Barbie. You're so good. All right, before that. Nope. There it is. Ah! All right. So, what you're seeing here are the 7 big ideas that NASA addresses with regards to Earth system science. And I like to do this with folks, especially teachers. So, out of these 7 ideas, as I read them off, I want you to listen and think about what you teach in your standards, in your curriculum. And I want to know how many of these 7 ideas you teach about this year. All right. We've got sun-earth connection. That could be, seasons, etc. We've got climate variability and change. We've got earth surface and interior. We've got weather, carbon cycle and ecosystems, atmospheric composition, and water and energy cycles. That's 7. Melissa's got 6 out of the 7. Who can beat 6 out of 7? All of them. Jennifer's got you beat, Melissa. Justin says all. Matt and 2 others are typing. So we're going to hear for, okay, 3 out of 7. All right. So we've got, looks like 3 for Kimberly. Scott is typing here. So what I'm stressing to you here is that it might not be obvious. NASA's not in the publishing business of getting in with these educational publishers, and so a lot of our content and tools are not making it into the mainstream curriculum that you're seeing with Houghton Mifflin and other kinds of Glencoe and that kind of thing. But we have data, we have resources, and so if you were one of those that you're teaching 7 out of 7 of these ideas, let's please look for ways to connect your students with the real world data that NASA is collecting. And so now is the time, Barbie, to push out. Thank you so much. So some of these videos that I am sharing here, I actually have created YouTube videos from Karen St. Germain's presentation. She's the NASA Earth Science Director, and she gave a great presentation where we're building context of why this is important. And so what you're seeing here is the connection with Earth science and NASA data, and certainly frames out what we know and what's happening with our climate. And we know it's changing, right? So we're at average about 1.2 degrees Celsius hotter than we were during the pre-industrial times. And so we know, based on our data that we're collecting and the information that we're building, that we know that the increased greenhouse gases, we know these are contributing to that. They're trapping heat in the Earth's atmosphere, and they're not only trapping heat in the Earth's atmosphere, but it's affecting the conditions on land, ocean, and the atmosphere. And so we're generally warming. Next slide. All right. So and if you teach earth science, many of us know this, with heat capacity and the properties of water, building these essential physical science concepts into earth science, we know that most of that energy goes into the ocean, right? And so really it's delaying the full impact of this global warming. We know that ocean currents, they're really the great distributors of this heat, right? And to move the heat around. But what's happening is it's impacting our local weather and climate. And the warmer the oceans, they accelerate the melting of ice sheets in Greenland and Antarctica. And so rising seas are a major consequence of climate change. We hear this even with more frequency now. And so who's impacted most? I shouldn't say most, but who's impacted? It's certainly our coastal communities, our infrastructure, our economy. I live near Norfolk, Virginia, which is constantly on the news. And a phenomena that we experience in Norfolk is called sunny day high tide flooding. And so we see this more and more. It's where these the high tides ride on top of the sea level rise, which is so it's inundating our coastal areas. So we'll go ahead and next slide, please. All right. So not knowing where you all are from, many of you might say, well, so why should I care about sea level rise, right? I live in the inland part of the continent. It's not something that my kids care about or see often, but let's think about this. Although many of you may live far from those coastal regions like Norfolk, Virginia, right? You're not far from feeling the effects of these. And so what I'd love to hear right now, what are some of the effects you think that you see that are linked to climate change and a warming ocean? So Melissa is sharing some ideas, certainly impact weather patterns, more extreme weather, drought Dave is seeing in the Southwest, absolutely. Gina is typing and two others. Bigger winter storms, absolutely. Intense rainfall events, 500-year plus scales, yes. Humidity, all right, keep it coming. So when we think about it, like all of that water that we need to sustain life inland, to grow crops and to drink, all of it comes from the ocean, but it's delivered to us by that water cycle, right? And we are in the beginnings to see that this increase of the magnitude of the water cycle. So wet regions are getting wetter and dry regions are getting drier. And so these are ways for you to think about what are the environmental phenomena and events that you're seeing in your neck of the woods, and how might we connect some of these NASA data and tools so your students have the experience of, of perusing them and engaging with these tools and interacting with them. Excuse me. So, and I can't remember who said it. We were talking about severe storms, but one of the ways that wet regions get wetter certainly is the intensity of those tropical storms and hurricanes. And we know that as they pass over warm water, they intensify. And so I love this image to the left. You can see this hurricane forming over this warm water, and you can see the trail that it's leaving. It's like it's pulling that heat right out of that water. And all that heat, really, in those oceans that we talked about before, that becomes fuel for these severe storms. So we're seeing more and more hurricanes, and they're intensifying, and they're intensifying more rapidly, right? They're getting bigger, stronger, faster. And then, of course, which we've seen, I think, with Ian and some of the others, then what do? They deposit that moisture over the land when they make landfall. But some of those storms we see like stall for long periods of time, which can cause extended flooding. Have you guys put in the chat if you have experienced in the last couple of years some of those tropical storms like stalling in your region? Okay, you're mentioning some good things. You're teeing me up, Jennifer, for the next part. All right, so if we could go on to the next slide, please. Excuse me. So what you're seeing here is a tool that NASA has created, and this will be on your handout. It is called the Sea Level Projection Tool, and you can see here on the left-hand side, we're modeling for you how to explore data. It's really neat to use, but this tool helps to make the IPCC report real to people. And the IPCC report, excuse me, the IPCC, it stands for the Intergovernmental Panel on Climate Change. And this is a scientific group assembled by the United Nations to monitor and assess all global science variables related to climate change. And so I think it's about 6 to 7 years, they generate these reports that report on all different aspects of climate change around the world. And so when you interact with this tool, you're able to find out what we know about sea level in different regions, and then we're able to project into the future what communities are facing. So check this out. This is one of those tools that you don't need a lot of prior knowledge to be able to jump into and evaluate. I probably it might not be all elements of this might not be appropriate for elementary or middle level, maybe depending on the class and the students, but do check it out. All right. And one of the things that I did want to mention, if we can go back to the slide deck. One of the things I've not done well is, let me go back, is showing you the linkages. Now, can I share my screen? I'm going to click on this shrinking shorelines and developing deltas. This is the EO Kids. All right. So excuse me as I navigate this. Okay, we're here. I'm going to share. Barbie, let me know when you can see my screen.
I can see it, and just so you know, you've got about 17 minutes left.
Oh my gosh. Okay. So this is EO Kids here. We've got the different issues that are found on the right hand side. I'm looking for the shrinking deltas, which is down here. I'm going to open this up so you can see kind of how it's organized. You can download the PDF. All right, so we've got some information. We've got satellite imagery. It looks like Landsat. We have key vocabulary defined. You can see these vocabulary boxes. Thinking like a scientist, so we've got some engagement opportunities here with different activities. Now, this one doesn't have necessarily a hands-on, something to build, etc. But I wanted to show you that, let's say, you're not, these standards are not in your wheelhouse to address at this level, but I want you to think about using these EO Kids activities and articles. And I'm going to go ahead and stop sharing. And all of these, again, are linked on your sheet. So the next thing, if we could go back to the slide deck, I'm trying to think. All right. Okay, no. And someone mentioned before about farming communities, and so this is really where we see a lot of impacts from climate change inland. Especially along those waterways where we have these agricultural regions, and even the agricultural yields are being affected. So from what I understand, I'm not an expert in this yet, but I'm learning so that I have recently learned that there are two ways that climate change impacts agriculture. And again, regions are getting wetter, and some drier regions are getting even drier and receiving less moisture. So we see, and we know how that's linked with wildfires and other events that we're seeing out west. I love Sharon's just mentioning NASA Eclipse, Where Do Crops Grow, is a great practical video to share. These are incredible resources. They have different resources for different grade bands. So definitely check those out. We need to make sure that those get into this handout. But one of the things we might not think about is that when temperatures rise, plants' demand for water also increases. So, this combination of increasing temperatures and these crazy kind of precipitation patterns affects these drought conditions, and they can really have giant lasting effects on agriculture around the world. And let's see here. So, okay. Yes, great. Perfect. All right, so what you're seeing here, and these are animations that NASA Science Visualization Studio has created. So what you're seeing here is that we are able to actually project out the impacts on agriculture. And so why should we care? All right, so what we're seeing here is maize on the bottom left, or corn. We're seeing wheat yield projections on the right-hand side. So as you're looking at this, the red areas have lower yield while the green areas have higher yields, right? So you can see, and this is 2099, you can see that wheat maybe gets a little bit more favorable in these areas. Corn, maybe not so much. But what kind of impact does that have? Why is that important? Well, I mean, so much of our food comes from corn, right? And animals' diets, things that we feed them. Also, many household products. Like I learned that there's adhesives, wallpaper, batteries. There are many things that use corn. So we've got to really think about the impact to agriculture. All right, next slide. All right. So what I'm going to do now is I'm going to let's see. I'm going to skip all this. I want to show you some things that can help us learn as we become better educators of earth science information and data. We have, through NASA's Earth Science Data Systems, we have resources for you. And they are not necessarily resources for teachers, right? And they're not going to be resources necessarily for students unless you are teaching. And I know we have Katrina that teaches high school technology and engineering. Unless you are teaching data science, maybe an AP environmental science, maybe AP biology. If you're teaching at that level, maybe some of these resources would be appropriate. But we have backgrounders. So if you're like, so Elizabeth is mentioning this remote sensing. What in the world? Like, what is this? That is something that we have resources to help you find and learn about. We also have what we call data user profiles. And so, many of these are university folks, right? But the thing I want you to think about, especially if you are in these in the high school level, is that when you're looking for opportunities to engage students in real data and real problem solving, check out some of these data user profiles to learn about the research questions these people are asking. You don't necessarily have to access the same data sets and go about it in this super academic manner, but what you can do is you can have those topics and those data sets inspire you and your students to put together some practical research projects. As I mentioned here, Earth Observatory's got great resources to use to learn more about. The bigger thing is about finding the data. We've got it, but how in the world do you find it? And this is one of the big, data discovery is one of the big things that people complain about NASA or science. And so I would be remiss, can I share my screen? And I know time is running. I knew this was going to happen, but that's okay. But, it is what it is. Let me share my screen with you. All right. So this is our website. It's called Earth Data, Open Access for Open Science. And this is where you will find all things NASA Earth data. And we have attempted to break these down into different pathways where you can figure out kind of where you fall in this audience of and users of data. Do you need to learn more? Are you ready to find data, or are you ready to use data? And so I'm actually going to go up here to Earth, up here to Learn. And I kind of like starting here. The thing I'm going to show you here is something called Data Pathfinders. And Sharon, this might be something of use to you as you're building out resources for your informal audiences. We have something called Data Pathfinders and I'm just going to open one. And I know we don't have a lot of time, but we have a variety of different topics. But I'm going to disasters. So the disasters data pathfinder is actually broken up into different data pathfinders. We've got one for tropical cyclones, one for earthquakes and volcanoes, et cetera, et cetera. So Dr. Paget, I'm thinking about you. I'm going to go ahead and select extreme heat, right? Because urban heat islands, near and dear to my heart. Within these data pathfinders, what you're going to find is some background information. You're also going to you're going to be presented with the primary categories or types of data that you could use in your inquiry. And so here we've got temperature data. We have humidity data. We have land cover data, weather maps, and socioeconomic data. Okay. Now, and I'm going to just go to land cover. So we're going to look at land cover, and I'm thinking about my biology teachers here. So when you open these, oh, that's my father-in-law. Sorry about that. So as you open up these data pathfinders, there's a bit of information here that's provided, and then there's some links that you can download data. Now, the first one here, it says download MODIS land cover type from Earth Data Search. Well, given what I know about this audience, primarily, you might not want to do that. It's a bit more advanced. It's not as sequenced and helpful. This is really for those experienced data users. But what I encourage you to do is check out NASA Worldview. How much time do we have? Not a lot.
7 minutes.
Okay. So what I am showing here, and I don't know, we got this, all right, let's back up. Actually, it looks like it's loading, so I'm not sure what's going on. NASA Worldview is an incredible tool that it it shows it's pure image driven, meaning that we can see almost what these sensors are seeing in near real time within the 3 hours or 3 to 6 hours. So if you're engaging your students into looking at different phenomena, check this tool out. And I'm going to go fast. I'm so sorry about it, but I want you to look here. You can type in your location. Tennessee State University. Okay, hopefully it's there. I probably didn't spell something right. There it is. All right. So you can take pictures, you can share these links. I want you to note this. So you can share this link and point directly in your lessons to this. If you want students to analyze these data, there's a quick way to do it. So check that out. You can also embed it into your website and social media, etc. Okay, so I'm going to add layers. I know this way too fast and I'm so sorry, but you can search for different variables by their topic. So look at this. So we've got droughts, floods. You can add these data. You can also search by science discipline. I'm more of a disciplinary kind of thinker. So for me, if I'm a biology teacher, I'm going to go to the biosphere and select those data. Let's see, so I'm going to just leave it at that. I also want to show you that there are events. So if you're like, whoa, Trigger, I don't know anything about what's going on. I need a primer on like what are some of the earth science events happening. This is going to show you. So check this out. Tropical Storm Carl, October 13th. That's today. It's going to show you where it is. You're going to be able to see different aspects of it. And you can even, all right, so let's see here. In some cases, you can download those data. By this tool. We do have nighttime lights and some other data, but it's going to take you to Earth Data Search, which is that more advanced tool. You can also do comparisons. I know we don't have a whole lot of time for that, but you can do comparisons pre and post. You can, do the swipey thing. You can do a spyglass. And this is a pretty neat tool. So yes, that's a thing. You can actually also do animations with this, and you can share those animations, but we don't really have time for that. So I am going to bounce back to, I'm going to stop sharing. Can we pull up the slide deck again? I'm so sorry we're out of time. It's such a bummer. You like get into this and then. All right, so we talked about data pathfinders. I'm not going to talk a lot about this. Really, as you're thinking about what kinds of tools you use, I want you to think, are your students at the place, and maybe you as an educator, where you really need to, use those visualizations, that imagery-centric kind of resource? Or are you one of those that are a pretty savvy data user, like maybe Katrina, where you want to provide your students with opportunities to get into the weeds with the data? There are options for you. There's also this older NASA resource that was published during Earth Science Week. And hey, by the way, happy Earth Science Week. That it's an oldie but goodie, but I love it. And we put it on MyNASA Data. I've put the link here, but here's something I want you to think about. This provides a guide for selecting what tool you use. So we've got here, can't read that, whatever that says, but we've got NEO, we've got Google Earth Engine, and it shows you kind of like, okay, this is introductory, this is intermediate, this is advanced. We have Globe, we've got MyNASA Data, and you see Worldview is here in that green. So check that out. Again, MyNASA Data is awesome. For those advanced users, if you're a computer science teacher, if you're doing code, code.org or something like that, or AP Computer Science, and you're looking for kids to develop their own apps and stuff like that, we've got resources for you. We do have APIs for our data. We've got webinars, we've got tutorials, and really this is for that advanced user. I'm not doing that. Then finally, with like the very little amount of time we have, I'm going to talk to you about mission biomes. So for my life science teachers, I want you to consider mission biomes. The coolest feature about this, they are connected to NGSS, to the 3 dimensions. They've got all that mapped out. But the thing I love so much about this is it's teacher created. It's not NASA people. And they provide you 2 different activities, and the 2 activities are scaffolded. One's for a beginning data user and one's for an advanced. So if you've got, let's say you teach at different levels of life science, for example, and you can, I'm so sorry, you can you can do that in terms of having students do different kinds of activities based on their needs.